Then they'll go after, there's a death tax, they'll go after, okay. All right, so today we're going to go over the last topic in this unit, and that is the idea of the mole and the mole equation. Now, we are not talking about the little rodents, okay? We are talking about an amount of things. Why they called it a mole, I don't know, but that's what they call it. Actually, when you see the guy who invented it, maybe you'll understand. Okay? No, he doesn't have a giant mole like the guy in Austin Powers, which, by the way, is very funny. Okay? But he does kind of look like that. I don't know if it's just the cut of his suit or what, but he does kind of look that way. So, the idea of the mole was to give us a more standard unit of measurement to use when dealing with numbers of particles. Okay? What's a common number that we use when we're talking about amounts of things in daily life? One. Okay, I'm thinking of, like, we use a word, but this word represents the same number all the time. Okay, a couple.
Oh.
What else? Dozen? Yeah. Okay.
A few.
A few. Well, a few is always a different number, though.
He's
Not always. A few could be 4 or 5.
No, it's 3.
Okay. For you it is. Okay. But we do have some that are defined, right? Like couple is always 2. Dozen is always 12. Well, a mole is always this many. .02 times 10 to the power of 23. And you're probably looking at it, that is so random. Okay? Except that it isn't. Okay? That number is actually not random at all. It seems like it at first glance. Okay? But it was arrived at by using the simplest element. That would be hydrogen. This, when it was initially calculated, is the number of hydrogen atoms in 1 gram. So if I had 1 gram of hydrogen gas, I would have this many molecules. Or sorry, this many atoms, not molecules, this many atoms of hydrogen. Okay? And then that number was then applied to everything else. That is where we get all these atomic masses from that are on our periodic table. Every one of these atomic masses is what we call the molar mass of that particular element. So if I had 6.02 times 10 to the 23 atoms of lithium, it would have a mass of 6.94 grams. Okay? If I had 6.02 times 10 to the 23 atoms of oxygen, it would have a mass of 16 grams. Okay? That's where those atomic or molar masses come from. And is this idea of the mole. Now, do you need to memorize that number? Yes. You don't. It's on the back of your periodic table. Okay? It is just one of those numbers that is important. You're going to use it so much that you will inadvertently memorize it, okay? But you don't have to. Okay? It is on the back of your periodic table. Okay, so the mole is this unit of measuring the amount of particles of a substance. Okay? Doesn't matter what I have. If I have 1 mole of it, I have how many?
6.03 times 10 to the power of 23.
That many. Yeah, 6.02 times 10 to the 23. In the same way that if I say I have a dozen eggs, I have 12 eggs. Say I have a dozen donuts, I have 12 donuts. Okay? It's always representing the same. All right? Okay. Now, we will eventually have to get to using the mole equation to solve problems. That is going to involve algebra. Okay? This is the mole equation. N equals little m over big M. Because, you know, chemists have to be difficult. There are 26 letters in the English language. They used M in a 3-variable formula twice. And the only other letter they used sounds like the letter they used twice. N equals M over M. No, I say. Okay? But that's the way it is. So we just have to remember. Now, in this equation, obviously each part of it represents something. We will get to that, and we will get to how you manipulate it. Here's the good news for the mathematical part of it. You'll only ever be asked to solve for little n or little m. Big M, you can always calculate from your periodic table, so you'll never have to solve for it algebraically. Not that it's difficult, it is after all just a 3-variable formula. if you have visions of triangles dancing in your head right now, keep it to yourself, because I'm going to tell you exactly why triangles suck later. Okay? All right. Yes, you can tell I'm a physics teacher because I hate the damn triangle. Okay? No, not so much that I hate chemists, it's just triangles, because they're a crutch. And eventually you have to get off of crutches and walk again, or learn to walk. And that's what I'm going to teach you. Okay? All right. So, we can express the amount of things in lots of different ways. We can say we have this many grams, so we can use mass. We can use volume, we have this many liters, okay? Or we can use moles, okay? Moles tells us probably a bit more accurately the number of particles of that particular material. Now I say particles because it depends what I'm dealing with, okay? If I'm dealing with an element, like beryllium, and I have 1 mole of beryllium, I have 6.02 times 10 to the 23 atoms of beryllium. But if I'm talking about a mole of water, I don't have 6.02 times 10 to the 23 atoms. I have 6.02 times 10 to the 23 molecules, because the smallest particle that is water is a single molecule, not a single atom. Does everyone follow me there? Okay, so when we're talking about the mole, we are always talking about the smallest unit of that material. That's why we use the word particle instead of atom or molecule. Particle covers both. Okay, we just have to understand that if we're dealing with a compound, we're dealing with molecules, and if we're dealing with an atom, or an element, sorry, we're dealing with atoms. Okay, everybody okay with that? All right, so that number we just talked about, the 6.02 times 10 to the 23, that is Avogadro's number. So when you hear me say Avogadro's number, okay, that is that mole number. Okay, Avogadro is the guy who came up with the idea.
Is he the mole-looking one?
Yes, he's the one. Yeah, you'll when you
Is
see
that
him
him right there?
No, that's not him. And that's not him there either.
That's the last.
That's actually a mole.
Oh.
And keep the shape in your mind when you see him, and you'll see the similarity. I figured like his nickname must have been the mole or something. All right, questions so far? Now, we can abbreviate mole, so if you're writing moles and you're really, really busy, and, you just don't want to write the whole word, you can abbreviate it mole.
I feel like that'd take more time because you have to do 2 parentheses and a period.
No, you don't have to put it in brackets. You can just write MOL.
Oh.
Yeah, MOL.
But E is the easiest
LOL.
letter.
What's that?
Actually, I is the easiest letter.
Okay, but look at our society. Okay, we have an abbreviation for at. Okay. Huh. And
I feel like that's harder to write than that.
I think so too, but that's how busy we are. Can't write the whole word at, so we do this instead. Okay.
I feel like that came from the texting email.
We have an abbreviation
Okay, so one of the things in the mole equation, big M, okay? Big M in the mole equation stands for molar mass. Okay? It is the mass of 1 mole, or 6.02 times 10 to the 23 particles of that particular material. If you're dealing with an element, you just read that number directly off the periodic table. If someone says, what's the mass of 1 mole of magnesium, you would say 24.31 grams. What do you do if you have a compound? How would you figure out the mass of 1 mole of a compound?
Add them together.
Add them together. Okay, so if I'm being asked, calculate what's the mass of 1 mole, or the molar mass of water, okay, I simply punch in what the molar mass of all the parts are. Okay, now, how many hydrogens are there in water? 2, okay. So there are 2 hydrogens. One hydrogen is 1.01, so 2 hydrogens are going to be 2 times 1.01, or 2.02. Okay, and I'm going to add that to oxygen, 16. So what that tells me is if I have 1 mole, or 6.02 times 10 to the 23 molecules of water, I will have 18.02 grams of water. its molar mass would be 18.02 grams per mole. Okay? You want to follow how I did that? Is it terribly difficult? Do you know how people get them wrong? They don't get the formulas right. Yeah, they forget drops and swaps or things like that, and then they don't get the number right because they don't have the formula right. Okay? Otherwise, it's just adding and multiplying. It's pretty straightforward stuff. Okay? All right, is 18.02 grams very much?
No.
No. This is about a tablespoon. A tablespoon's 15 milliliters. This would be 18.02 milliliters of water. There are 6.02 times 10 to the 23. That's 6.02 with 21 zeros behind it. That's that many molecules in a teaspoon. Okay, sorry, tablespoon of water. Okay? All right, atom's small. It gives you an idea when you start looking at it in practical terms. Like the amount of water I could put in basically the cap of a water bottle, okay, contains a lot of molecules of water. All right, I would like you guys to calculate for me the molar masses of these compounds using your periodic table. Okay? Let's say for now, let's just do the first three. All right, so if I want to calculate the molar mass of sodium chloride, how many sodiums are in this molecule? One. Okay, so I take the atomic mass of sodium, 22.99 grams per mole, okay, and I add it to how many chlorines? One. Okay, so 35.45 grams per mole. Okay, and so when I put those together, I guess can take a minute for my calculator to fire up here. Emulator.
Oh.
So it emulates the real calculator like this. Okay, 22.99 plus 35.45. Okay, 58.44 grams per mole. Okay, how important are units? Very important. If you just write 58.44, I don't know whether that's apples, oranges, old ladies with walkers, elephants with arthritis, okay? I don't know, okay? You have to tell me what the units are, otherwise the number is meaningless, okay? All right, number two, I've got iron and bromine, so iron 3 bromide. So for iron, we're looking at 55.85, okay? Is there just one iron? Yeah. Okay, how many bromines? 3, so 79.9, okay, times 3. All right, so we're looking at 295.55 grams per mole. Okay, everybody all right with that one?
Do we have to show our work like that, or can we just multiply before we?
If we're doing a mole equation question, you can just write in the molar mass. That'd be fine, but for this exercise, just because it's the first time we're doing it. Okay. For this one here, we have diphosphorus pentaoxide, so phosphorus is 30.97. Yeah. Okay, and there are 2 of them, plus 16 times 5, because there are 5 oxygens. I always get phosphorus and sulfur mixed up. That's 30, it's right, 30.97. Okay. All right, 30.97 times 2 plus 16 times 5.
That calculator has a sun on the up arrow. It's brightness.
Yeah, for brightness. 141.94 grams per mole. Okay, so remember, anytime we calculate this number, we are calculating the mass of 6.02 times 10 to the 23 particles of that material. Okay? All right, here's where they get hairy. Think math, parentheses. Okay, you got parentheses. The number outside the parentheses means multiply everything inside the parentheses by this number. Okay? So you have to do this element by element. You are not going to find the molar mass of ammonium. Okay? It's not on your periodic table. You're going to have to do the nitrogens and then the hydrogens and okay? That's what, oh God, this is so hard. Life is hard. Okay, okay, so for number 4, okay, we're, again, doing this element by element. How many nitrogens do I have here? 2, okay? In ammonium, there's 1 nitrate. The brackets say there are 2 ammoniums, or sorry, 1 nitrogen. Okay, the brackets say there are 2 ammoniums, so there are 2 nitrogens. So I take nitrogen, multiply it by 2, plus, how many hydrogens do I have? 8, okay? How many sulfur?
1.
Yeah, just 1, okay, 32.07. Okay, and oxygen, there are 4 of them, 16 times 4. All right, so if I take those, okay, I'm going to have 28.02, that's my 2 nitrogens. There's my 8 hydrogens, 8.08, my sulfur, and my oxygen. All right, so 132.17 grams per mole. Okay, is it a little bit tricky? But it's not terrible, right? As long as you remember math rules, we're okay. For our last one here, we got scandium carbonate. Okay, so there are 2 scandiums. I have no idea what this is. 44.96. Okay, times 2. So there's my 2 scandiums. Okay, plus how many carbons?
2, 3.
3. Okay, because there's 1 carbon in carbonate, but there are 3 carbonates. So 12.01 times 3. Okay, and there are how many oxygen? 9. Yeah, 3 times 3. And so 16 times 9. All right, so 44.96 times 2 plus 36.03, that's my 3 carbons, and plus 16 times 9. All right, 269.95 grams per mole. Okay, everybody okay with how that one works? Basically, just reading numbers off the periodic table and putting them together. Okay, nothing too difficult. But it is a crucial skill, fundamental skill, for doing mole equation calculations because you always need big M, the molar mass, when you're doing a mole equation calculation. So being able to calculate those correctly is important. Okay, so when we look at chemical equations, okay, and we do the balancing, okay, we've always kind of looked at it from a very literal perspective. That is that in this reaction, there is 1 molecule of nitrogen reacting with 3 molecules of hydrogen to produce 2 molecules of nitrogen trihydride. Would I even notice that reaction? No. Okay? But those coefficients don't have to mean literally 1 or 2 molecules. They can mean moles. Okay? So I have 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas to produce 2 moles of nitrogen trihydride. Would I notice that reaction?
Yeah.
Yeah. Okay? I mean, it's still going to be small. That's still small amounts of things. But I would notice it because I would have 28 grams of nitrogen. Okay? I would have 6 grams of hydrogen, and so on and so on. So we can look at that as bigger. Okay? The numbers don't always have to be literal. When you get to Chem 20, one of the first things you do is what's called reaction stoichiometry. And it means using the mole equation and the coefficients on a reaction to predict not just what the products of the reaction are, but how much product you would get. Okay, so if it told you you have a reaction between 28 grams of nitrogen and 6 grams of hydrogen, how much, well, I mean, that would just be an addition on it. It could be something more complex, but you could figure out how many grams of something you would get in a synthesis reaction. It's easy, you just add the two masses together. But if you had a double replacement reaction, okay, you might have to figure out how much of this compound am I going to get versus how much of this compound am I going to get. Okay? In the end, it's not that hard. You just have to do mole equation calculation. Okay, so as we were saying, we could look at it in terms of particles. Okay, the literal way we were looking at it. Okay, we could. Oh, there's. Doesn't it? I don't know if it's like the cut of his suit that makes his neck look really long and his shoulders really small, or if it's the sunken eyes.
The big nose.
Or maybe it's both.
It might be the
Could be
big
both.
nose too.
Yeah,
And the blind shots.
I don't know. It just, he looks like a mole.
It looks like he's hair.
Okay, no, just to have a little bit of fun. Okay, so let's look at the mole equation here, guys. Okay, so the mole equation, N equals little m over big M, okay, where N is the number of moles. Okay, and so the units for that would be, obviously, moles, right? M is the mass of the material. Okay, that's going to be in grams. And big M is the molar mass. Okay, and obviously that is in grams per mole. That's the stuff we just learned how to do a few minutes ago. Okay, so right now the mole equation is set up to solve for moles. If I divide mass in grams by molar mass in grams per mole, the grams cancel and I'm left with moles. Yeah, okay. Grams divided by grams per mole, the grams cancel and I'm left with moles. Okay. What if I want to solve for little m? How do I get little m by itself?
Moles divided by molar mass.
Would I divide? If I want to move something in algebra, I do the opposite. That's rule number one of algebra. Okay? Rule number one of algebra is if I want to move something, I do the opposite. What's rule number two? What I do to one side of an equation, I have to do. It's the golden rule of algebra. Okay? What I do to one side, I do to the other. Okay? The third rule of algebra, okay, won't apply to this formula, but it is that you move what's not attached to what you're looking for first. Okay? It would come into play in a different kind of equation, which we'll talk about in a minute. All right, so if I want to solve for little m, I would simply, whoops, thought I had the pointer up. Okay, I would simply multiply both sides by big M. Okay? I multiply. If I want to move something, I do the opposite. I was dividing by big M. So to move it, I multiply by big M. I multiply both sides by big M. And now I'm solving for M, little m. That is the only manipulation of this equation you are going to have to do. Is that very hard? Okay. Do you need a triangle for that? No. Okay. You do not need a triangle for anything because triangles suck. Okay? So let me give you an example. You're going to use this formula in math and science. If I want to solve for m, I want to get m by itself. What should I move first?
Get rid of the b first?
Get rid of the b, because that's the third rule of algebra. Move what's not attached first. B is not attached to m. Okay? Now, I have to go back to the first rule of algebra. If I want to move something, I do the opposite. And what I do to one side? Do to the other. Okay, so I'm going to subtract b from both sides. What's b minus b? Right, so now that's gone. But now I have to subtract b from this side as well. So now I have y minus b equals m times x. How do I get m by itself? Divide both sides by x. That wasn't very hard, was it? Okay, did you need a triangle for that?
No.
There isn't a triangle for that. Do you know why? Triangles only work when you're multiplying and dividing a 3-variable formula. So once you're past 3-variable formulas, this is a 4-variable formula, triangles don't work anymore. Okay? You get into physics 20,
I bet we can do that in octagon.
got a triangle for that? Maybe a rhombus?
Octagon, maybe?
Yeah. Something? No. No shape is going to work for that. You just have to know the 3 rules of algebra.
Have you tried finding shape?
No, because I don't need to. I can just follow the 3 rules of algebra, and that's
But
easier.
shapes are fun.
Okay. Well, not in math, they're not. Oh wait, they're part of math. Not in physics, they're not. Okay, so yeah, like you're going to get these formulas, like this one. Plus or minus VOV plus or minus VS. Okay, you got a triangle for that one? Or this one? M4 pi squared times R over T squared equals big G times M1 times M2 over R squared. Got a triangle for that?
I think that's a triangle for
Yeah, okay.
I bet we could do that. I think a triangular prism.
So the point I'm trying to make here is, of course, that you don't need a triangle to do algebra. Okay? And I know that somewhere along the way, some well-meaning, good-hearted teacher showed you that triangles can do math for you. They lied. Okay? That they can only manipulate 3-variable formulas, which once you're done 3-variable formulas, that would be right now, you can't use them anymore. Okay? They become useless, and you have to be able to stand on your own 2 feet and do algebra. Okay? Algebra is not hard, guys. Okay? You are looking at a person who was not in high school or university a terribly strong math student. Okay? I passed introductory calculus by memorizing the examples in the textbook, writing them down in my final exam, and getting part marks for method. Okay?
That was smart.
That was the only thing I could figure out how to do. Luckily, there were at least 49% of the class who were just a little dumber than me. Okay? Because on the curve, that means I passed. Even though I didn't actually pass the test. Because more than half the class did worse than me, I passed. Actually, I think my introductory calculus teacher was actually pretty good. In terms of the profs I've had, he was really good. I could understand him, like his speech, I could understand what he said. I just didn't understand what he was saying, okay, or what he was doing. It didn't make any sense. I understood the first day, and after that I didn't understand anything, okay? And so I'm not a terribly strong math person. Like I'm helping, my son's in grade 11, and he's doing math 1, and like, I can't help him. I teach physics, but I can't help him, okay? Because I can do algebra. That's all I need to know how to do, okay? If I follow those 3 rules, got me through university physics. And I did good in university physics. I got 100% in one, okay? Because I can do algebra. Okay? It's not about, you don't have to be good at math to do algebra. Okay? Algebra is just following rules. Okay? If you follow the rules, you can do algebra. Okay? Understanding how to do math, that's different. Okay? And it's not that people can't do it. Okay? I mean, I sat down and did math 10 with my son last year, and I kind of figured out how most of it worked. Could I teach it to somebody? No. Okay? But I figured it out, and so can you. Okay? It's not, don't be afraid of it, is basically what I'm saying. Algebra is not that difficult, and you can figure it out.
Isn't physics just memorizing equations and plugging in numbers?
No, absolutely not. That's, I mean, how you end up with answers at the end. But you have to be able to understand, in physics, you have to understand what is going on and the relationships between things to get to the math. So what I always tell people is, you're actually in physics better off to be like me and not be terribly strong at math, but understand how things work. I have had tons of people come into my physics class who are gifted at math, incredibly gifted at math, but they can't do physics. Because they're just like, I want to do the math. Well, then go do math. Okay? If you can't see the physics and understand what's happening in it, you can't get to the math. You don't know what math to do. If I show them, here's the math to do, they can do it 100% every time. But you have to know how to get to it. That's the challenge in physics. So, most of the people I've taught who did best in physics were good at understanding physics, not necessarily good at math. Doesn't mean if you're good at math, you can't be good at physics. You can't totally. Some people are really good at both. But I've found that really gifted math people don't always get physics. All right, making sense? Triangles, not good. Okay. All right, we're going to walk through a couple of mole equation questions here. And this is what we're going to do kind of each day for the rest of the unit. I'm going to walk through. There's only 4 ways for me to ask a mole equation problem. Only 4. Each day I will go through one example of each one of them. Okay, so we'll do 4 problems at the beginning of every class that shows you, here's how to do these 4 ways, the only 4 ways I can ask a mole equation question. Okay, so by the time the unit exam comes, you'll be like, oh yeah, I know that's method 1, that's method 2, that's method 3. All right, so write this one down and we'll walk through it. This is the easiest of the mole equation questions. Okay, so the first step in any problem-solving question, be it mole equation or physics, is to write down our givens. That is, what information did the question tell me? Okay, so how many moles? What does the question want me to find? N. It wants me to find N, the number of moles. Okay, it tells me that it's calcium chloride. What can I figure out if I know what the compound is? Molar mass. So I can get big M. All right, so big M is going to be 40.08, that's calcium, okay, plus 35.45 times 2, which should be 110.98 grams per mole. Okay? All right, and 90 grams, what did they give me there? The mass, little m. Okay, you would get 1 mark for that. Okay, you figured out what the molar mass was, you wrote down the information the question gave you. Okay. That's the formula we're going to have to use. Well, duh, it's the only formula we know already. Okay, of course that's the one we're going to have to use. Okay, do I have to manipulate it? No, it's already set up to do what I want. Okay, so all I have to do basically is plug in my numbers. 90 grams divided by 110.98 grams per mole. Right? So you get a mark for this step. Okay? And then you would get a mark for your final answer. All right, so we're looking at 0.81 moles. That would be a 3-mark question. There's not much to do in that, right? There's no algebra. You can have to manipulate anything. Okay, questions on how that one worked? That's method 1. That's the easiest type of mole equation question because you weren't required to do any algebra. You just had to plug numbers into your calculator. Okay? All right, here's method 2. All right, copy this one down and we'll walk through it in a minute. Okay, so what is the mass? What are they asking me for? Little m. Okay. Of 4.5 moles, what did they give me there? N. Of magnesium bromide. Okay, now this one's a little trickier because they gave me the word, they gave me the name, not the formula. All right, so I've got to do this then. Magnesium bromide. That's a +2, that's a -1, so MgBr2. All right, that's going to be 24.31, so the atomic mass of magnesium, okay, plus 79.9, the atomic mass of bromine, times 2, because there are 2 of them. Okay, 184.11 grams per mole. Okay, so you get a mark for that. Okay, now I know I have to use this formula, n equals little m over big M, but I'm trying to find little m, so what do I have to do with big M? Multiply both sides by it, right? Okay, so when I multiply this side by big M cancels. I multiply this side by big M. Now I've got big M times n equals little m. All right, so you would get a mark for the algebra. Okay, and then you would get a mark for plugging in your numbers in the correct place. So n would equal 184.11, big M, times, oops, sorry, little m, okay, times 4.5 n. Okay, so this is going to be in grams per mole. This is going to be in moles. When I multiply those together, the moles will cancel, and I'll be left with grams. Is that the unit for mass?
Yes.
Okay. Okay, so I'm going to have 828.50 grams. So that would be a 4-mark question. Questions on that one? Okay. Methods 3 and 4 involve another step. Okay, you'll have to do a mole equation calculation, and you'll also have to use Avogadro's number, 6.02 times 10 to the 23. You can always tell you're doing a method 3 or method 4 question if the question either asks for or gives you the number of particles. Okay, so if the question was to say, ask you, how many molecules of water are in 50 grams? Okay, as soon as you see that it's giving you or asking you for a number of molecules, you're going to have to use Avogadro's number. Or it might ask you, what's the mass of 5.7 times 10 to the 25 molecules of sodium chloride? Okay, it gave you a number of molecules, you're going to have to use Avogadro's number and then do a mole equation calculation. Okay, so it's not really any harder, there's just an extra step. Okay, so that would be methods 3 and 4, which we will start off tomorrow's class. We won't start tomorrow's class with that. When we go over to the lab at the start of tomorrow's class, and then we will talk about the other 2 methods and get to work on this stuff. I will be posting your unit exam review by the end of the week. Okay?
When's our unit exam?
Yeah.